In this last section of Chapter 9, we want to do a recap of some of the big highlights of what we've done in Chapter 9. In particular, we've learned 4 confidence intervals so far, and we want to be able to distinguish between them and know when to use which one. So in section 9.1, we learned about how to create a confidence interval for a proportion. So that's when you want to know the population proportion P, but you only have the sample proportion P hat. Remember, I had the little box of beans, and then the scoop of beans was my sample, Then I counted the red beans out, and that was created my sample proportion. And that's a metaphor for working for surveys and polls, those kind of things. What percentage of people approve of the president's job? What percentage of people are going to give away Halloween candy this year? What percentage of tires make it past 40,000 miles, etc. When you're talking about a percentage, a proportion, you're working with P hat and P. Now, the distribution we use to make that interval is the Z distribution, the standard normal distribution, which remember always has a mean of 0, a standard deviation of 1. We learned that in Chapter 3, actually, but we've furthered it in Chapter 7. And you can tell that it uses the Z distribution, by the way, because when you look at the formula, which is over here, it has Z alpha over 2 in there, right? And don't forget, while we're on the subject, that alpha is the complement of your confidence level. So if you have a 90% confidence level, alpha is 10%. And then alpha over 2 would be 5% because you divide that alpha in half. Now, where do we get this on the calculator? It's in 1 prop z int. So let me grab that real quick. So stat tests 1 prop z int is up there at letter A for me. There we have it. And this is one of the simpler things we enter into the calculator. You tell it X, which is the number that were in the group that you wanted. So the percentage of people that approve of the president, or the percentage of people that are going to give away Halloween candy. This particular one was the number of red beans in my scoop, that kind of thing. And N is the number of people you called altogether, the total in the sample. Then you just put in your confidence level as a decimal and press calculate, and it's done. And notice it gives you P hat at the same time. All right, so there's that. Then we learned in section 9.2 the confidence interval for the mean. Now, we didn't have the population mean, and therefore we use the sample mean, which is x bar. That forms the center of our interval. That's called the point estimate. Whereas for this particular one from 9.1, p hat is the point estimate because that is the center of the interval. Notice I put up here that it's the point estimate, right? So the statistic you use this as the point estimate is p hat for proportions. It's x bar, the sample mean, for mu, the population mean. So x bar is the point estimate. And we're going to use a t-distribution with n minus 1 degrees of freedom. And you can tell it's a t-distribution because the formula itself uses t alpha over 2. And then it has s, which is the sample standard deviation, the same sample standard deviation you were finding in Chapter 3, right, with the calculator. Now, when you want to find this interval with the calculator, you use the t interval. So if I go to stat, tests, number 8 is the one. So if I grab 8, which is t interval, you have a choice, data, if you actually entered a column of data into your calculator, or stats, if you just have the statistics. Like x bar is, I don't know, I'm just going to make it up, 52, and the standard deviation is 3, and my sample size was 45, etc., etc., etc. Okay, then you would go down to calculate and press enter like that. If you didn't have the statistics given to you, you'd have to enter the column of data, like right here. I have a column of data right here. Then you go to stat, calculate, tests. There we go. Stat tests, number 8, t interval. And then you would choose data. Tell it your column. I'm in L1 or wherever. Always leave frequency as 1, always. And then confidence level, enter whatever your confidence level is, and go down to calculate and press enter. You're only allowed to use the data feature if you have data entered into L1 or L2 or L3. If you don't have that, then it must be given, X bar and S and N must be given to you in the problem. So if they give you X bar, S, and N, S being the standard deviation, X bar being the sample mean, and N being the sample size, sorry, S is the sample standard deviation. If that's the case, then you can use stats. Oops, I pressed the wrong thing, stat. There we go. So if they have a column of data, use data, but you have to enter it yourself first. If they give you the statistics, X bar, S, and N, if they give you these three numbers, then you can use this stats feature. All right, so that's that one. Then we learned the confidence interval for variance and standard deviation. And of course, they're very similar to each other. So if you want to estimate sigma squared, which is the population variance, you'll use S squared, which is the sample variance. Similarly, if you want to estimate sigma, you'll use S, which is the sample standard deviation, to estimate the population standard deviation. And that distribution uses the chi-square distribution. It also has n minus 1 degrees of freedom, okay, with n minus 1. There we go. All right, and this is not in your calculator. You're going to have to use the table, the chi-square table, to find the two chi-square values of alpha over 2 and 1 minus alpha over 2. We learned all of this in section 9.3. Now keep in mind that there's a couple things going on here. First of all, alpha, remember, is the complement of your confidence level. Then alpha over 2 is that cut in half. And then 1 minus alpha over 2 is the complement of that. So for example, if I had 90% confidence, alpha would be 10%. Then alpha over 2 would be 5%, and 1 minus alpha over 2 would be 95%. And use that 0.05 and 0.95 in your table to find your values. Let me pull up the table real quick. There it is. So for 90% confidence, you'd use 0.05 right here and 0.95 right here. And then use the degrees of freedom that is closest to your values. So if you have 20 degrees of freedom, use 20. But if you have 33 degrees of freedom, you use 30 because that's the closest one you can get, right? Or if you had 42, you'd use 40. 48, you'd use 50. You'd round up. All right, and also remember, by the way, a couple of other things about chi-square. They're not the same. So in the z distributions, you're able to use the same number for the plus and the minus right here, because the z distribution is symmetrical around 0. Same with the t distribution, it's symmetric around 0, so it's the same number both sides. But the chi-square distribution doesn't have that. You're going to have two separate numbers you're going to have to find for creating a confidence interval. So you find both those two numbers, you put them in, and then you run that calculation with your calculator. But you'll have to type it in. There's no standard issue confidence interval generator like there is for these two, the t interval and the one prop z interval. Now remember also that when you want to find the confidence interval for standard deviation, all that is the square root of the one for the variance. So it's easier often to find the one for the variance and then just take the square root at the end. All right, couple more things before we leave the confidence interval pieces behind. The tables, if I go back to the tables real quickly, remember that the t table is a quick way to get access to a lot of the t critical values. Not all of them, because there are a lot of degrees of freedom that aren't in here. For example, degrees of freedom 52 is not in here, or 67 is not in here. So you could use your calculator to find those. But a lot of degrees of freedom are represented in here. And you have your area in your right tail in this table because they only have to give you half of them, because the other half, of course, are all the negative values. And then you'll notice that most of these t distribution values are between 0 and 3 or 4, 0 and 4. Remember, the chi-square ones are up in the 40s and 30s. Heck, you get down to the hundreds over here. You get some pretty crazy values, whereas the preponderance of the t values are much smaller. Also remember that the bottom row of the t distribution has the z values down here, and you can use those z values to help be a quick reference for yourself for finding critical z values. I will definitely give you one that is not in that table that you'll have to find by hand using inverse norm with the calculator. But this still has plenty of values for you to work with. All right, then one other thing before we head out of here. The confidence interval formulas themselves and which part they are in the calculator does not have to get written on your note sheet because it's already in the inferential statistics info sheet, that green packet in your course pack that you get to use on your exam. So you can see here, one sample proportion, I tell you what to use on the calculator. It's one prop z int, I even tell you what section you learned in, which is section 9.1, and then I give you the formula. And it should be very, very obvious to you that you need to use z alpha over 2, that this is the z distribution. It would probably be wise to put your p hat formula somewhere. P hat is x over n, somewhere on your note sheet. And then the one sample mean uses the t interval, so that's right here on your info sheet. Again, your point estimate is x bar, that's the center of your interval, and you're using the t distribution with alpha over 2. And then the other ones we learned in chapter 9 are right here. The ones for the standard deviation, which is sigma, or the variance, which is sigma squared. But of course, they're really basically the same thing. It's just that this bottom one, you've taken the square root of the top one. Or vice versa, for the top one, you've taken the square of the bottom one. All right, so that's everything we've learned for confidence intervals. And then let's remind ourselves of the sample size formulas. Remember, these answer the question of how many. For these two, it's how many people do I need to call up on the phone to know the president's approval rating? How many people do I need to call to poll about who's going to vote in the next election? That kind of thing. So this one is when you have a prior estimate. You have some old study, some old survey. So for example, for the presidential approval rating, they did it a week ago. So they have last week's. So they have a prior estimate. It was last week's estimate. For what percentage of people are going to vote in the next election, they have the last election. So they've got prior estimates from that. If you have no prior estimates, you never studied this before. You've never asked this question of anybody. So you have nothing to gauge it from. And if that's the case, then you use this formula right here. Both of these, by the way, are for proportions though, for surveys. How many people do I need to call up to ask this question? How many people do I need to poll to ask this question? For the mean, however, that's different because you're not really polling things necessarily. You are, how many tires do I need to sample to know the average life of a tire? How many people do I need to sample to know the average body temperature? You're looking for an average. Now keep in mind, you could do proportions with tires as well. Let's say I want to know what proportion of tires last longer than 50,000 miles. Well, then I'd get a sample of a big number of tires and then I'd see how long they last, etc. So I could do that. It wouldn't be for the average age, it'd be the proportion of tires that last a certain age. So it doesn't have to be people you're calling up here. And this particular one is for the mean. And notice that all of these use z alpha over 2. They can't use t because t relies on degrees of freedom, and degrees of freedom, you'd have to know your sample size, and of course that's what you're looking for in all of these. So when you're asked for a sample size question, look for how many people, how many tires, how many jelly beans, how many whatever do I need to go get to sample, right? How big does my sample need to be? If it's asking about proportions, it's one of these two. No, with a prior estimate, without a prior estimate. And then it's asking for the mean, for the average, then it's this formula. Oh, and also don't forget the error in these two often will say 4%, which means you'll have to change it to a decimal, 0.04 for these ones. That's a pretty common mistake that students make. If it says 4% error, they'll say 4, but it's actually 0.04. And how do you know what error is? Well, when you look at the problem, it'll say I want within 4 percentage points. Within is your error. Over here, they'll say, I want to be within 20, kumquats, or within 20 inches, or within 20 feet, or whatever. Within. What they talk about within, that means that's your error. And don't forget that S is your sample standard deviation. The same sample standard deviation you've known since chapter 3. Often these problems, it'll be given to you in the instructions. So you'll just have to read and figure out which part is the sample standard deviation. And then the z alpha over 2 gets calculated from knowing your confidence level. So if it's a 90% confidence level, you'll go to your table here and you can find 90% means that the edges are each 10% total, so 5% each, and you'd see that it would be 1.645 right there. Of course, there could be one that isn't in this table, but a lot of those problems, they'll just use one of the quick reference z alpha over 2s. All right, so we are done with section 9. Oh, real quick before I go away. Those same formulas, by the way, are on your inferential statistics sheet right here. So you don't have to write them on your note sheet for your exams. They're right here in this inferential statistics packet that you get to use on your exam. And with that, we are done with section 9.4, and therefore we are done with chapter 9. I'll see you back here for chapter 10 when we cover hypothesis.